Hello everyone. In this video, we're going to be solving an interesting trigonometric problem. We have sine of cosine of x equals cosine of sine of x. Now, where does this problem come from? You've probably seen it before. And this problem was actually suggested by one of my viewers, and thank you for the suggestion. And we're going to be looking at this problem right now. So this problem was suggested by Clement Hajrullah. Is that how you say it? Hopefully I didn't say it wrong. So we're going to look at this problem. We have sine of cosine of x, and that is equal to cosine of sine of x. First of all, think about this problem. See if you can spot real quick solutions. And then we're going to go ahead and solve it. And at the end, we're going to look at a couple different things, including a graph, which is pretty interesting. So to be able to solve this problem, I want to turn these into the same thing. I have a sine and I have a cosine. And I want them to be the same kind. So let's go ahead and replace this cosine with a sine of something. As you hopefully know, cosine of alpha can always be written as sine of pi over 2 minus alpha. So if two angles are complementary, this is true. And then you can go ahead and use it here where this is going to be our alpha. So sine of cosine of x can be written as sine of pi over 2 minus sine of x. Because in this case, sine x happens to be the angle. Make sense? And it's the sine of another angle. So now we have sine of A equals sine of B. How do you solve those kinds of equations? There are actually two solutions, right? One of them is going to be to set them equal. And then the other solution is just going to consider the fact that they can be supplementary, right? Because if two angles add up to 180 degrees, their sines are also equal. So let's go ahead and consider those cases. Case 1, cosine x is going to be pi over 2 minus sine x. And of course, I need to add multiples of 2 pi. Let's just add 2 pi n, where n is an integer. And at this point, it makes sense to put all the sines and cosines on the same side. So let's go ahead and add sine x. And then this kind of gives us the sum of these two things. Obviously, you can square both sides, so on and so forth. There's other things you can do too. But no matter what you do, here's what happens. Cosine x plus sine x has an upper bound. It needs to be less than or equal to square root of 2. In general, I should say a cosine x plus b sine x is always less than or equal to the square root of a squared plus b squared. Make sense? So, in this case, cosine x plus sine x is going to be less than or equal to root 2, right? But why is that important? Because if you look at it carefully, pi is about 3.14, pi over 2 is 1.5 something. It's definitely greater than root 2. So, in this case, what happens, since pi over 2 is greater than root 2, which is the maximum value for this function, then we don't have any solutions. To be more clear, we don't have any real solutions, because as you know, those boundaries are only true for real values of x. So, no real solutions to this equation. But let's go ahead and look at the second branch, and then we will make a determination for that as well. For with the second equation, you can basically say that, okay, one of the angles, which is cosine x, is going to be pi minus the other one. So it's kind of like pi minus pi over 2 minus sine x, right? And then plus 2k pi. And then here, you're going to get something like pi minus pi over 2 plus sine x plus 2k pi. And that's going to equal cosine x. Now, pi minus pi over 2 is just going to be pi over 2, right? So we can kind of write this as cosine x minus sine x equals pi over 2 plus 2k pi. Again, we have the same issue because this is greater than root 2. So we're going to proceed the same way. But let's go ahead and take one of these, right? Because they're going to be very similar. How could you solve an equation like this for complex solutions, okay? Or for non-real solutions? And for simplicity's sake, let's just assume that n is equal to 0. So we're looking at pi over 2. If n does not equal 0, then obviously you're going to be adding multiples of 2 pi. If n is positive, it's going to be like pi over 2 plus 2 pi, which is going to look like 5 pi over 2, and then so on and so forth. It doesn't matter. It's pretty much the same idea. That's why we can just stick with one version and, solve that way. So, how do you find complex solutions to this? Again, there are different ways to go about it. One of them is basically you could square both sides, right? That's definitely going to help. And when you square both sides, you're going to get cosine squared plus sine squared plus 2 cosine x sine x equals pi squared over 4. And this sum is 1, as you know, hopefully. 1 plus 2 sine x cosine x, I just like to write it that way, equals pi squared over 4. And hopefully you recognize this, right? This is the double angle formula for sine. In other words, sine of 2x. So from here we get sine of 2x equals pi squared over 4 minus 1, which can be written as pi squared minus 4 over 4. Now think about it. Do you think this is also greater than or equal to 1? It should be. Because the sine x plus cosine x was greater than root 2, we're basically out of the boundaries. Make sense? Okay. So, what are we looking at? We have the sine of an angle, but that is greater than 1. So, the solutions are non-real. How do we handle the solutions in this case? Again, Euler's formula comes to the rescue. For simplicity's sake, I can go ahead and set the 2x to alpha because I don't want to deal with the double angles. And then sine alpha equals pi squared minus 4 over 4. To be able to solve this, I'm going to replace sine with the following. E to the I alpha minus e to the negative I alpha divided by 2i. Remember from Euler's formula, and we've just done a problem on the other channel, a plus bi, which is very similar to this, right? So from here, we should be able to solve for e to the I alpha. And to be able to solve for that, you can just go ahead and replace this with another variable. Let's go ahead and call this t. Then we kind of cross-cancel a little bit here. And then maybe write this as t minus 1 over t equals pi squared minus 4 over 2 times I. And this is going to turn into a quadratic equation. So, to be able to solve this quadratic equation, what do? We can go ahead and